Kia ora koutou. Welcome to the last video on the properties of metals. In this video we'll be looking at the hardness, solubility and melting points of metals. Melting points is the only property that I've been able to find a past exam question for. So we'll still go over hardness and solubility, but melting points seems to be the main one that we need to remember. All of these properties are related to the same thing about the structure and bonding of metals that gives them all of these properties, and that is the strength of the metallic bond. So remember, this is the structure of a metal. We've got the cations in a sea of delocalized valence electrons, and between all of these cations, the electrons form a metallic bond between the cations around it. And so each electron will form a bond with all of the cations nearby. So I've just done a zoomed in version of that. So we've got this electron is attracted to the nucleus of the nearby metal cations. And so this is the metallic bond, and it is very strong. So it's a strong metallic bond. So we'll look at hardness first. So hardness is the ability to resist being permanently deformed, and it's directly related to the strength of the bond. So different metals have got different strengths, and we can see that by their melting and boiling points, well, mainly the melting points. Some like sodium or lithium, you might have done the experiment in class where the teacher will cut some lithium or sodium and put that in water. And so the very fact that you can cut the sodium with a not even that sharp a knife shows that it's not incredibly hard and doesn't have a huge melting point, whereas something like aluminium or titanium does have a much larger melting point, and so they are harder. But in general, we say, even though some metals are harder than others, we say that all metals are hard, and that is because of the strength of this bond. So because of the strength of this bond, metals are able to resist force being placed on it, and they're not deformed by a weak force in general. But then if there is a force that is great enough to deform a metal, they don't shatter, and we've gone over that in the malleability video. Solubility, so we'll look at solubility of metals. So if we were to have water molecules around this metal structure, first of all, there's no real attraction between, well, the attraction between the water molecules, even though it is a polar molecule, and the metal is not strong enough to overcome the metallic forces. So these metals will stay in their 3D lattice, and the water will just continue to interact with itself. Moving on to the last one, so the melting and boiling points of metals, we've got this past exam question. So circle the substance which has the lowest melting points. You've got aluminium, magnesium chloride, and sulfur. Justify your choice referring to the attractive forces between the particles of all three substances. So in this case, molecules, we've gone over this in a previous video, molecules have a very low melting and boiling point, so that would be the lowest one. We know that ionic compounds, so this is an ionic compound because it's got a metal and a non-metal, and this is a metal because it just has a metal there. We know that metals and ionic compounds have really high melting points, and that is because of the strength of the bond. This question is saying justify your choice referring to the attractive forces between the particles of all three substances. So in this case, we just need to refer to the attractive forces of the substances. We don't need to talk about the structure and bonding like we normally would when we're explaining the properties of a substance. So we'll just go over the metal part of this question. So we'd say aluminium is held together by strong metallic bonds. And so what's important about melting points is the energy required to overcome these bonds, or the kinetic energy or the high temperature. So we would say these bonds require a large amount of energy to overcome. we could say for the substance to melt, therefore has a high melting point. You'll never have to distinguish between whether a metal or an ionic compound have a higher melting point. We just kind of categorize ionic compounds and metals as having high melting points, and then they'll often be compared to a molecule which always has a low comparative melting point. So that's all for this video. Thanks very much for watching. Like and subscribe for more Chemistry 2.4 videos. See you next time.